Okay, dear students, in our previous discussion, we see about the unit 1 and unit 2. So, normally our unit 1 is energy auditing. So, for energy auditing, main equipments are motors and lights. So, in the second unit, we see about the energy efficient motors. So, in the third unit, we will see about the lighting and energy instruments for audit. So, coming to the third unit, the syllabus for the third unit is lightning and energy instruments for audit. So under that, various topics are good lightning system, design and practice, lightning control, lightning energy audit, and next energy instruments such as watt meters, data loggers, thermocouples, pyrometers, luximeters, tongue testers, and applications of the PLCs. So these are the various contents present in the unit 3 of our energy auditing and demand side management, and last unit for the energy auditing. So coming to the lighting design. So first of all, what is design? Design is the science and art of making things useful to the humankind. So lighting design means is the application of the lighting including daylight when it is specifically used as a source of lighting to human spaces. So the design considerations of the lighting system mainly in three ways. So what are those three ways means? Lighting quantity, lighting quality, and implementation. So in the lighting quantity we will discuss with task illumination concept, and in the lighting quality we will discuss with light distribution and space and workspace considerations and lighting on people and objects. And the third topic is implementation. So economic or cost considerations and energy sustainability is the main points regarding the implementation. So lighting quantity. So for general purpose lighting purposes, the recommended practice is to design for a level of illumination on the working plane on the basis of the recommended levels. So task illuminations means the task illuminance describes the amount of light falling on a surface. It has two components: amount of light based on the usage or multiple usage of a space. And if the surface is horizontal, horizontal illumination, and if the surface is vertical, vertical illumination. Some tasks through are at an angle, such as reading a book in a hospital bed, etc. So with some angle and some horizontal illumination and vertical illumination. So coming to the lighting quality. So lighting profoundly affects many human reactions to the environment. So these human reactions range from the obvious, such as the dramatic beauty of an illuminated landmark or the emotional responses of a candlelight dinner, to suitable impacts on worker productivity in offices or sales in retail stores. So the lighting quality can be explained mainly in with three subtitles. So what are those three subtitles? Light distribution including, and space and workspace considerations including, and lighting on people and objects including. So under the lighting distribution including, further we have the three topics. Those three are nothing but task and ambient lighting, and daylight integration, and light pollution and light trespass, and the space and workspace considerations including flexibility and appearance of the space and luminaries, and color appearance, and the luminance of the room surfaces, and direct glare and reflective glare. And coming to the lighting on the people and objects including the modeling faces and objects and surface characteristics and points of interest. So all these are we will see one by one. So under that, first topic is light distribution including. So in the light distribution including, what are the subtopics? Task and ambient lighting, and daylight integration, and light pollution and light trespass. So task and ambient lighting. The task lighting systems independent from the space's general lighting systems are found in building types. For instance, the display lighting in retail stores is a form of task lighting. So similarly, task lights are used in the industrial manufacturing and assembly, healthcare and residential lighting and many more interior lighting applications. So ambient lighting. So task lightings can't light the balance of the room, and thus some other types of the lighting systems is needed to produce the ambient illumination in the room. So task ambient lighting produces the energy savings in two ways. So locating the light source close to the task most efficiently produces the illumination levels needed for the task, and task illumination levels don't have to be maintained uniformly throughout the space, so ambient levels can be lower. So this is about the task ambient lighting. And next, daylight integration. So practice of using windows and skylights and other forms of the fenestrations to bring light into the interiors of the buildings using the various means. So incorporating daylighting in the lighting design can be done by proper control of the fenestration, luminance, and daylight sensing and compensation control systems, which allow the adjustments to electrical lighting system, and glare control should be also be incorporated in the design. And light pollution and light trespass. So in outdoor lighting, electric light may illuminate adjacent properties, which become the offensive if unwanted, is known as the light trespass. And electrical light parts emitting the light upward of reflecting light upwards cause a condition called light pollution, which causes the moisture and particles in the air to glow at night. So several steps to minimize the light pollution and light trespass. So use the night lighting only when and where necessary, and use the minimum amount of the light needed rather than the maximum. So use source with cutoff optics that restrict light to the intended area of the illumination, and use more sources, each of lower wattage, to improve the uniformity in the intended illumination area and the minimize trespass into the adjacent areas. So space and workspace considerations. So up to now we discussed the about the light distribution including. So now space and workplace considerations including. So under space and workplace considerations we have nearly six subtopics. So what are those? Flexibility and appearance of the space and luminaries, and color appearance and luminance of the room surfaces, and direct glare and reflective glare. So under that, space and workspace considerations including, first one is the flexibility, and the second one is the appearance of the space and luminaries, and third one is the color appearance, and fourth one is the luminance of the room surface, and fifth one is the direct glare, and sixth one is the reflective glare. So coming to the flexibility. So advanced lighting designs should be flexible enough to ensure that lights operate where needed and are off where not needed, as people move around within a space and use rooms in different ways. And spaces used for the hoteling, the occasional or transient use of the workspaces remain dark unless needed. The lighting space system can be rapidly reconfigured to match a changed floor plan or accommodate a different space use and still operate at maximum energy efficiency. The lighting system permits multiple uses and on-demand flexibility in multiple use spaces such as conference rooms and modern AV rooms. AV rooms means audio and video classrooms. And next, appearance and space of luminaries. So luminaries efficiency and the ability to use efficacy sources have become increasingly important criteria for selecting luminaries. So designers should find lighting systems that embody the project style or aesthetic, but to do so using high efficacy sources and effectively principles. The appearance of the color, both in terms of the CRI and both in terms of the CCT. So CRI means color rendering index and CCT means correlated color temperature, are important in the overall feeling of the space, and in some instances can have a dramatic effect on the visual talks. So what is meant by CRA? CRA describes how a light source makes the color of an object appear to human eyes and how well subtle variations in color shades are revealed. The CRI is a scale from 0 to 100%, indicating how accurate a given light source is at rendering color when compared to a reference light source. The higher the CRI, the better the color rendering ability. Halogen is considered the reference light source and has a CRI of 100, and CRI of 100 in a LED sources has not yet been deployed, and CRI in the 90s possible but very expensive, and fluorescent lamp sources are considered very poor in the CRI running in the low 70s. So a CRI index greater than 80 is considered as very good color rendering index. And CCT, so for a good visual comfort, and light needs to have the right color and quality. Light can feel color or warm. This is quantified by the color temperature and is measured in degrees kelvins. The higher the color temperature, the bluer the light is. This may be seem counterintuitive as we think of blue as the cooler color than red, but it comes from the physics of the black body radiation. So people generally prefer bright light to be bluer like daylight, while they prefer dim light to be yellow like candlelight, and the color temperature of the daylight and various common light sources are as shown in the figure. And next, luminance of the room surfaces. Periodic trends in interior design introduce dark paints and finishes. So these trends contribute to difficulty in producing the energy effective design by increasing the lighting requirements to raise surface luminance into the comfortable range. And lighting designers should encourage the use of the high diffuse reflectivity surfaces and minimize the use of the dark surfaces. And a direct glare, this is also one of the topic in the lightning quality. So caused by the lightning, the direct glare caused by a view of the light source often when the high contrast to the surroundings. So glare is associated not just with lamps but also with daylight, especially when one is exposed to low angle direct sunlight. Be concerned more about the glare caused by lamps, lenses, and other overly bright sources of the man-made lights, less about glare of the sunlight and the small point sources. Most concerned about the sources of glares in relation to the stationary tasks when building occupants cannot easily relocate themselves or their tasks. And reflective glare have long been associated with the glass coated copper paper, pencil paperwork and computer CRT screen. Reflective glare, when system has been optimized to reduce the glare, then consider and modify the task to eliminate remaining glare problem, such as use of the flat screen CRT or active matrix. So use of the link rather than the pencil, and use of the matte coated or uncoated paper rather than the glass coating paper, and changing the finishes of polished floors or shiny conference room tables, etc. And the lighting on the people and objects including. This is also comes to the lighting quality concept only. So under that we have three topics: modeling faces and objects, and surface characteristics, and points of interest. So modeling faces and objects. In human vision, shadows and highlights enhance the perception of three dimensions. Both are products of the directional light sources. The sun and the moon produces the well-defined shadows and are considered dramatic and attractive light sources. Diffuse light, like the light from the cloudy sky, and produces an even light that is relatively shadow free. Once considered desirable, it is now realized that shadow free light can fail to render the changes in the surfaces, making a space or task less visible. To model a surface for better recognition of its shape and features, in general, some percentage of directions lights is considered important. Considering using a blend of direct and indirect lighting in most design to provide a combination of the comfort and modeling. To achieve the minimum modeling, a directional light for an object or area of interest should be at least 20 to 25% of the total illumination. And surface characteristics, lighting techniques that reveal the architectural nuance like texture enhanced visual perception have become the more commonly requested by building owners and architects. And point of interest, in retail and museum lighting, designers use highlights of up to 10 times the ambient light level to draw the attention to key display, and recognize that it's wasteful to create lightning than is indeed needed. Carefully select highlights and use a minimum effective highlight level, and creating highlights in the contrast to the lower ambient illumination levels, and creating the highlights with efficient sources as close to the objects or surface as possible. Small points of the light from the fiber optic sources or LEDs may offer efficient ways to create the highlights or attract the attention where the specifically desired. So these are the 3 points regarding the light quality. And the last topic is implementation. So the energy efficiency depends on the implementation. So the energy efficiency lighting design focuses on ways to improve the both the quality and the efficiency of the lighting. Match the amount of the quality of the lighting to the performed function and install the task lights where needed and reduce the ambient light is elsewhere. Use only energy efficient lighting components and controls and systems. These include fluorescent and LED lighting options. Maximize the use of the daylighting, and daylighting is the use of the windows and the skylights to bring natural light into your home. So this is about the various design considerations of the lighting design.